Why do you believe what you believe? My students often believe things like drinking alcohol on a cold Saturday during football season will warm them up, or going outside with wet hair will cause them to catch a cold. When I ask them how they have come to trust those assertions, they often draw recourse to authority figures like parents or maybe even their own experiences. One of my favorite philosophers, Charles Sanders Peirce, suggests that our tendency to draw certain types of inferences and thus settle doubt is a habit of mind. In my last presentation, I discussed several attitudes necessary for conducting good research. If held, those attitudes help constitute a habit of mind akin to a scientist whose sole concern, according to Peirce, is to settle opinion in a particular way. For people who are passionate, curious, and persistent, an irritation of doubt will certainly arise that cannot be settled by other ways of knowing. Tenacity won't do. It seems impossible to go through life systematically keeping out of view all that might cause a change in our opinion. Likewise, relying on authority may work in some cases, but in general, preserving belief because of tradition or my mother said so seems ill-advised, especially for matters of any importance. And while it may be tempting to allow our inferences to be drawn from what Peirce calls the a priori method, or things agreeable to reason, otherwise in harmony with our own unique experiences, some of the most interesting findings from science suggest that many things go against intuition and that our experiences don't tell the whole story. Peirce suggests science as a method for fixing belief that is determined by some external permanency, by something upon which our thinking has no effect. The test of whether I'm truly following the method is not an immediate appeal to my feelings and purposes, but on the contrary, itself involves the application of the method. So today I want to briefly define how I see this thing that we call the scientific method, and then spend most of our time with the nuts and bolts of design and data issues that you should face as you think about how to fix belief regarding listening and human communication. First, I want to be clear about one thing. Science is a way of knowing, with a big emphasis on a. Scientists are driven by the prime component of understanding. As the natural sciences were created to understand the natural world, the social sciences were created to understand the social world. Natural and social scientists alike are interested in sense-making, solving puzzles, understanding patterns, and investigating social problems. So to the extent that a researcher is interested in understanding a concept such as listening, she should be equipped with tools necessary to engage in that understanding. Second, I want to stress that I view most of what listening researchers do as scientific, even if numbers are not used to substantiate claims. The data that one researcher needs to answer her specific question may be different from the data that another researcher needs to answer his. Some of those data may come in the form of numbers, while other data may be presented in the form of a narrative. Either way, researchers are trying to make claims about the larger nature of listening in some specified context. They're trying to understand listening in all its complexities and subtleties. Thus, they are scientists. As a scientist, you'll face two primary sets of issues in the process of inquiry: those associated with designing studies and those associated with analyzing data. In terms of design issues, I see three primary issues that need to be addressed. The first is the population of primary interest. That is, what is the universe of objects about which you're trying to make some kind of inference? And notice here that I said objects and not people, because population can refer to things other than just the people of interest. So when a public opinion pollster calls a randomly generated list of phone numbers, she isn't interested necessarily in the people who happen to be called. She's interested in a larger population of people. But the media researcher interested in how nightly news portrays terrorism or the war on drugs, he isn't interested in the specific programs that were selected and analyzed. In this case, the population isn't people, but nightly newscasts. In either case, the focus of these inferences is on a population. The public's opinion in the former case, and the nightly news in the latter case. It would be quite burdensome if every time we had a question, we had to ask every relevant person or read or watch every relevant news story. Instead, researchers rely on samples, smaller subsets of the population. When a researcher uses a smaller subset of the population and then uses those data to draw inferences about the population, she's making a population inference, a statement about a population by generalizing a description of the data in the sample to the population from which the sample was derived. Many of the claims that we want to make about listening take the form of population inferences. What are the barriers to listening? What listening strategies do salespeople use, and are they effective? Are leaders also better listeners? Do parents who paraphrase their children have closer relationships with those children, and so on? Each of these inferences tries to make a generalization about some population. Perhaps the best example of population inference in listening research is the time study. Those studies that try to estimate how much of a person's day is spent listening compared to engaging in other communicative functions. The original of these studies was conducted by Paul Rankin, who asked 21 adults to record the types of communication activities in which they engaged every 15 minutes for one entire day. Subsequent studies have attempted to replicate this study using slightly different methods. For instance, Larry Barker and his colleagues collected responses from 645 undergraduate students at Auburn University in 1977 who were asked to think about their last 24 hours and to estimate the time spent in various activities. The most recent study reported data from 2007. In that study, Januszek and Wolven had 680 undergraduates at Maryland retrospectively report on a single day of the week that was pre-selected by the researchers. So some students were told to think about Monday, some Tuesday, and so forth through Sunday. Several aspects of these studies are relevant to the population inference that they're trying to make. First, none of them utilized standard sampling procedures developed to generate samples that are representative of the overall population of interest. The Rankin study clearly had merely 21 participants, and the Barker et al. And Januszek and Wolven studies sampled only from one U.S. institution. As Andy Hayes states, if the goal of research is to generalize from the data to some population of interest, we want to do our best to make sure that the sample is representative of the population. A sample is representative if it's similar to the population in all important aspects relevant to the researcher. It doesn't mean that the sample has to be exactly like the population in all characteristics, but clearly you want to be as close as possible to those central characteristics of the population to which you want to generalize. So if you were the media researcher who was interested in the nightly news, you clearly wouldn't want to sample the noon broadcast, for instance, and you would want to sample nightly news programs of primary interest. So if you were interested in, for instance, large markets, you would want to sample from those markets like Chicago and Los Angeles. Or if you were interested in rural areas or comparing rural and urban areas, you would clearly want to sample from rural and urban areas. Both the Barker team and Januszek and Wolven were interested in the time spent in various communicative activities of college students. And that's stated clearly if you read those articles. So their choice to limit data collection to college students is understandable. At the same time, limiting the collection to one institution is not. Indeed, I'm not sure how many people really care about how Auburn University or University of Maryland students spend their communicative time. Instead, we're interested in getting a more representative estimate of the population of college students, which would require sampling from a number of institutions. Both Auburn and Maryland, for instance, are large public universities with a research-intensive classification. Other types of institutions include private, community college, and Jesuit institutions which aren't represented. If there's a reason to believe that the individuals that are sampled in these two studies are different from individuals who were not sampled, then the estimates that are provided in these studies don't serve their intended purposes. It doesn't tell us much that 52% of students in this sample, or 52% of the students' time in this sample is devoted to listening, when we don't really know how that sample differs from the larger population. So if they were interested in collecting those data and generalizing to their particular student body, then there's no harm done. So for instance, if they were interested in developing a curriculum for their students that emphasize particular student needs, then they can sample from their particular institution, and I would assert that the samples that they gathered were representative primarily of their institutions in terms of demographic characteristics. But that's not necessarily the stated purpose of a time study, which is to figure out how people or certain classes of people in general spend their communicative time. So one type of inference that you can draw with research is population inference. When you want to know who is likely to win an election, whether a referendum is likely to pass, or, in our case, how students spend their communicative time. These types of inferences are fully reliant on the representatives of the sample. The only way to retain a fully representative sample is by employing some form of what's called probability sampling, like simple random sampling, which basically it begins with a database or a list of all of the people who are in the population, and then the researcher selects at random individuals from that list, or another method which is called random digit dialing, which is often used for telephone surveys. I'm not going to go into details of these sampling methods, but I have included some resources here, and there are other resources as well that you can access that give you more details about how to go about sampling in these particular ways. So of course, population inference is of interest, and sometimes we want to conduct our research to try to estimate what it is going on in the population in terms of a point estimate of something like how much time is spent listening. But that's not the only reason that we conduct research, and in fact there's other types of inferences that we might want to draw with research. Andy Hayes defines another type of inference called process inference as assessing the degree to which data conform to theoretical predictions. During the last presentation, I defined a theory as an answer to the question, why? And I also said that researchers primarily give meaning to actions, objects, events, and so forth through their placement within a theory. So concepts like listening then take on various meanings as they're studied through various theoretical perspectives. So when we're talking about theory-driven research, or research which primarily attempts to understand and explain some practical problem in a general and abstract way, the focus of inference making turns from population to process. With theory-driven research, we're less concerned with estimating the size of an effect, such as the comparison between time spent listening and time spent surfing on the internet, and we're more concerned with determining whether a prediction our theory makes about what should happen in a research study actually does happen. And so I'm going to use as an example my own work on the differential effects of supportive messages that we started with last presentation. I've replicated some of the slides here, and I'll talk through them briefly as a reminder as well. So as a reminder, a host of studies interested in population inferences have observed the fact that there are many ways in which a helper can provide assistance. These studies look not only at college students as well as adults who aren't in college, but also people experiencing things like cancer, individuals in AA or drug rehabilitation services, people who have HIV/AIDS, women who or families who have just had a child, and the list goes on. So there's a variety of populations, and we know sort of some ways of providing assistance are quite helpful and generalizable across these groups. Others can be detrimental equally well across these groups, and then there are also some specifics that are tailored to those groups. But we have a pretty good sense of those characteristics of messages that help and those that hurt. The typology of supportive messages that I work with that explains why some messages are likely to be perceived as more sensitive than others basically states that messages are more sensitive because they're more person-centered. Person-centered in the context of support is basically the extent to which messages explicitly acknowledge, elaborate, legitimize, and contextualize the feelings and the perspective of a distressed other. In other words, person-centeredness is a theoretical explanation for why some messages work better than others. It's because they take into account and adapt to the subjective, emotional, and relational aspects of communicative context. And then we can align messages on a continuum from very low person-centered messages, those that deny the other's perspective or deny the other's feelings, tell the person how he or she should act and feel, to those highly person-centered messages that explicitly recognize and legitimize the other feelings, help the other articulate those feelings, elaborate reasons why those feelings might be felt, and explore how those feelings might fit within a broader context. So the example we used last time, I gave a couple of high and low person-centered messages last time, and I'll play those again for you in the context here of a student is in a class and they have to get a B to get in their major and they make a D in the course. So I'll play those messages again just as a reminder of what they sound like. And then the low person-centered message. All right, so there's 30 years of research that finds that messages higher in person-centeredness lead to a range of positive outcomes, and messages low in person-centeredness tend not to do as well. But it's also true that sometimes the highly person-centered messages don't produce as much of a positive impact, and sometimes low person-centered messages don't hurt as much. And so the question here is why? Why is it that there's variability in the outcomes of comforting messages, and what are some of those differences that might explain that differential impact? My colleagues and I have proposed that the impact of supportive behaviors on outcomes is both a function of the content of the behaviors and how they're processed by recipients. One of the primary contributions of our dual process theory of supportive message outcomes is to suggest a reason why messages often have variable impacts on people's coping. In particular, the theory predicts that when individual motivation and ability to process are high, messages and other behaviors that require extensive thinking will have a greater impact than when people are motivated or unmotivated and unable to process those elements. One of the primary contributions of the theory is to suggest revisions of current thinking of how support works. And so we want to make process inferences and test those inferences. Over a decade ago, Burleson and Goldsmith theorized that supportive conversations are a process of facilitating reappraisals, such that emotional experiences, how you feel about a problem, result from the appraisals that you have about the problem. And so if you think a problem is very, very stressful and problematic, the conversation ought to turn that appraisal, sort of help you reappraise that situation in a different light. The graph that's on the screen now is a model that was actually tested by a team of researchers, Susie Jones and John Wirtz at a University of Minnesota. And so they published a test of this and basically found that highly person-centered messages impact emotional improvement because they stimulate the use of positive emotion words. And this stimulation of positive emotion words, when you get somebody talking in more positive emotion content, that leads to heightened cognitive reappraisal. In other words, they start to think about their situation in a slightly different light. and that these two mechanisms in tandem then explain the relationship between person-centered support and emotional improvement. So the question here is, why does a highly person-centered message have a positive effect on emotional improvement? And the answer to that is because people talk about that experience differently and then go about a process of reappraisal about the event. And what my current theory suggests is that when people are able and motivated to elaboratively process supportive messages, they will do so, and in these cases, and in only these cases, will these mechanisms be operative. In cases where people aren't highly motivated or who are unable to process the supportive messages, these sort of high thinking, high elaboration mechanisms are not going to work. In those cases, when people are unmotivated or unable, different mechanisms, particularly those that don't require a lot of cognitive effort, will be working. In other words, person-centered messages work through different mechanisms. There are different processes that explain their effects, and the processes that work are a function of how much cognitive effort people are putting into processing the messages. And so to test this idea, here's the prediction here. The mechanisms through which supportive messages promote emotional change depends on the degree of elaboration. And in this particular study, we were looking at how stressor severity as a variable that impacts the motivation to process messages impacts the mediating influence of positive emotion words and cognitive reappraisals. So in this study, there were 192 college students asked to imagine that they were experiencing one of two hypothetical scenarios that were manipulated to create moderately stressful and mildly stressful situations. After they were exposed to the stressor, they were exposed to either a low, moderate, or highly person-centered comforting message, and then we measured positive emotion words reappraisal, and after the conversation, or after the situation and the message, we measured how they anticipated feeling about the stressful situation. And so we tested three models. We tested the overall model, the one for all participants. We tested a model for only those people in the moderately stressful condition, and then we tested a third model for those in the mildly stressful condition. And so what we found was that in the in the model where we included all participants, we replicated the Jones and Wirtz data almost perfectly. In other words, we found the same thing that they found in their study. What we also found, however, is that when you separate participants into moderate and mild stressors, that you only find this mediating relationship for positive emotion words and reappraisal when people are exposed to the moderately stressful event. In other words, the high thinking mechanisms are only working when people are thinking highly about the content of the supportive message. In other words, there's support for the theory. We have confirmation of a process inference. One critique that I hear about this type of work, and not just this particular study, but just in general this type of work, is that the study was conducted using students enrolled in a particular type of college course at one institution who were conveniently accessible for use for this purpose. And to that I respond, yeah, that's exactly what we did. And then so the critic continues and says, so the results are not generalizable to people in general, or even college students. We still don't know much. And my response is that's unfair. The point of the study was to test a theoretical proposition. It doesn't matter if the participants were not randomly selected from some larger population of interest, because of the goal of the study was to test a process. So we know the process works for at least this sample of data. Future work can now go about testing boundary conditions for the theory. While it's possible that different types of people are affected differently by supportive messages, the mechanisms that underlie effects should be rather consistent. Focusing on surface level similarities of a sample with a population is too simplistic in this case. In other words, a second type of inference that's important for researchers to draw is of the nature of the processes underlying the effect of one variable on another variable. This discussion then also highlights a second inference dichotomy, I think, inferences of the correlational kind versus inferences of the causal kind. If researchers are concerned with causal relationships, as we often are in listening research, a more appropriate design is the experiment, and you saw an example of an experiment with the study that I just presented. An experiment, basically the core feature of all experiments is to, as Shadish Cook and Campbell put it, to deliberately vary something as to discover what happens to something else later. Experimental research involves the manipulation or pre-structuring of the environment and observing or measuring the reactions to that manipulation. The variable that's manipulated, or the element of the environment that is pre-structured, is often called the independent variable, and the variable that you're concerned about changing, the outcome variable, is typically referred to as the dependent variable. In the study of supportive communication that we just talked about, two variables were manipulated: the person-centeredness of the message, low, moderate, and high, and the putative severity of the stressful event, the moderate and the mild stressful event conditions. And each of these can be considered an independent variable, though in my theory, for my particular purposes, stress severity is also what's called a moderator variable, or a moderating variable. Its impact is thought to moderate the relationship between message content and the dependent variable, affect improvement. In other words, low person-centered, moderate, and high person-centered messages are supposed to have differential impacts depending on stress severity, and that's the nature of a moderating variable. Whereas the nature of a mediating variable is to explain the relationship between two variables. In this case, the theory that I talked about suggests that cognitive reappraisal and positive emotion words are mediating or process variables that explain the relationship between person-centered communication and affect improvement. And to complicate things even more, and this is the only thing I'll say about it, is in fact the model was a moderated mediation model that was the result of what the theory seemed to predict. So listed on this slide really is just the main vocabulary that's used in experimental work, what you'll find talked about in experimental work. If any of this is confusing, or if you haven't had exposure to this sort of vocabulary, you should consult some additional sources. I've got several that I've listed at the end of the presentation. So while I'm able to make causal claims with the data I collected, I've manipulated one variable and I've seen the effect of that variable on another. Oftentimes the only valid claim that a researcher can make, or maybe even wants to make, is that of a correlational nature. This sort of post facto research begins with a measure of the dependent variable and then retroactively looks at pre-existing subject independent variables and their possible influence on the dependent variable. And so post facto or correlational research relies on classification independent variables like biological sex, as opposed to manipulated independent variables, or those that are directly manipulated by the researcher. So, for example, you might be interested in how a person's typical communication style is related to his or her typical listening style. And you could answer that question by having participants fill out a questionnaire that assesses their general communication style and another questionnaire that assesses their general listening style. You would then run one or more types of statistical analyses to ascertain if those two variables are associated. And so post facto research is useful, but it's often misinterpreted. The only warranted conclusion that you can make with that type of research is that there is a relationship between the variables. Correlation does not prove causation. It's theory that helps the researcher determine if a particular cause-effect sequence makes more sense than other possible sequences, but it's experimental work that ultimately has to be conducted to adjudicate the possible sequences. Oftentimes, but not always, when a researcher utilizes survey methods, she's interested in making a population inference. However, A rather popular use of survey methods for listening research includes what's called scale validation research, work that seeks to test whether new measures of listening facets and constructs measure what they're supposed to measure. Although beyond the scope of this presentation, I think it's important for you to be able, in general, to determine the types of inferences that researchers are trying to make when they report results in published form, and perhaps more importantly for your projects, for you to be able to think about the issues of inference making as you go about designing your own research studies. A second set of issues that we'll address involves the data that you collect as part of trying to make inferences of some sort. So putting aside the issue of whether your data come from a representative sample, putting aside the issue of whether they were collected via correlational or experimental means, we're going to turn now to concern ourselves with how to go about presenting data in order to substantiate claims. It's important to first note that the role of data is merely to help you make principled arguments. As Abelson puts it, good statistics involves principled argument that conveys an interesting and credible point. Some subjectivity in statistical presentations is unavoidable. Data analysis should not be pointlessly formal. It should make an interesting claim. It should tell a story that an informed audience will care about, and it should do so by intelligent interpretation of appropriate evidence from empirical measurements or observations. And I'll add to this quote that it's not just the presentation of statistics that should conform to notions of principled argument. The presentation of data in any form, whether numerical or not, whether drawn from personal experience or experience of others, should tell the most coherent and meaningful story possible. Jan Bavelis makes an excellent case for abandoning the dichotomy often forwarded that separates what people call quantitative and qualitative research. Research that relies heavily on numbers to substantiate claims versus research that does not use numbers to substantiate claims. As she states, this dichotomy would require that all words, such as many, often, several, usually, and so on, be expunged from the word processors of qualitative researchers. And that seems like a pretty silly proposition to entertain. It is, however, true that researchers who rely on methods like in-depth interviewing or case study analysis or other phenomenological analyses and data techniques oftentimes and most often have different goals for the research. Not always, but often they have different goals for their research compared to someone who primarily conducts laboratory-based or even field-based experimental work. Individuals employing in-depth interviews or case study methods are typically interested in a particular case or a particular perspective. They're trying to understand the meaning of a particular occurrence from the perspective of those people involved. The goal may not be to draw large-scale generalizations of the population or the process kind. As we suggested earlier when we discussed process versus population inferences, two main goals of scientists are to understand the underlying mechanisms driving some relationship and to understand the size of an effect. And to do this, researchers often rely on numbers when making claims. One set of numbers used in research is referred to descriptive statistics, numbers that are solely a function of the data under question. So descriptive statistics basically means statistics that are describing the data at hand. And those include measures of central tendency, which include the mean, the arithmetic average of scores, basically all the scores added together divided by the total number of scores. The median, which is the middlemost score, so if you array the scores, if your scores range from 0 to 1, and you look at the scores along that axis, the middlemost number is the median. And then the mode is the most frequent score. So if out of 100 people, 22 people scored a 78, and that's the most people that scored a single number, then 78 would be your mode. There's also measures of variability. So whereas measures of central tendency tell you about the average or the most frequent, most commonly occurring score, measures of variability tell you basically how those scores, all of the scores, vary about that average. So measures of variability and measures of central tendency are oftentimes or should be reported together. So you have a lot of different measures of variability. Three of the most popular are the range, which is the difference between the biggest and the smallest score. The variance, which is a distribution spread. So if you have a variance of 0, it means all of the values are exactly the same. And the standard deviation mathematically is merely the square root of the variance, but definitionally is the typical deviation in the data set. How much do the scores deviate from the mean on average? Another descriptive statistics that we'll talk about in just a moment is the effect size. So if you have two groups of individuals, how different are those means in terms of the size of the difference, not just that they are different. How related are the variables if you're doing a correlational study, and then there's just some common R squared, Cohen's d, and eta squared are common statistics that you might find in published reports. Although a student of mine and I recently did an analysis of the listening journal, and very rarely do people report these statistics. And that's actually true for most social scientific research published in communication and social psychology journals, that the effect size isn't often reported. A second set of numbers that are used in research referred to as inferential statistics. The most common type of inferential statistic include things like t-tests, ANOVAs, multiple regression, and other techniques that fall under the general umbrella of what's called the general linear model. But each of these is a technique that relies on what's called null hypothesis significance testing. And null hypothesis significance testing basically involves making a probability statement that the data obtained from a particular sample is a certain degree likely to have come from a population where the null hypothesis is exactly true. And if that statement doesn't make a lot of sense, it's because it doesn't make a lot of sense. Because what you often get the impression of when you read published reports is that scholars want to make a claim about the null hypothesis. In other words, they want to figure out whether it's true or not that these two variables aren't associated in the population. But in fact, what null hypothesis significance tells you is the opposite of that, which is if I assume there is no relationship, how valid is my assumption? And so most of the time, the null hypothesis is cast as the hypothesis of no difference or no association. And so before you analyze data, you make the assumption when you use one of these techniques that I'm going to assume for purposes of this analysis that there is no difference between these two groups, or there is no association between these two variables. So in the case of supportive communication, a viable null hypothesis is that the person-centeredness of message content has no effect on affect improvement. But study after study suggests that that's not a tenable prediction, that several data sets using a variety of samples drawn from a variety of populations suggests that person-centered message content has a consistent effect on affect improvement. In those studies, reported would be a statistically significant result, usually in the form of an italicized p followed by a less than value and then the number 0.05, or p equals some number below 0.05. And what that means is that there's less than a 5% chance that the sample data that you obtained comes from a population where there's absolutely no relationship between, in our case, person-centered speech and affect improvement. A statistically significant result does not mean that the result will be replicated 95 out of 100 times. Although if you open a stats book, you will read that claim in many stats books, and it's just simply wrong in terms of what null hypothesis significance actually does. So it doesn't mean that you'll replicate your result. And it doesn't give you any information about the probability of the truth of the null. The null still may be true if you were to look at the entire population. And other studies may actually find a result that suggests the null hypothesis is a viable hypothesis. So your results, even if you find a statistically significant result, may still be a function of your particular sample. One can never be 100% absolutely sure about a generalized claim from a sample to a population. And that's basically all that null hypothesis significance testing tells you. Basically, statistical inference is weighing in a manner relevant to the substantive issues of your investigation two types of error. The purpose of data analysis is to allow you to examine the extent to which the data provide corroboration for the theory-based answer to your research question. It allows you to rule out some alternative explanations, particularly what's called sampling error. So when a researcher reports a statistically significant result, she's basically saying that sampling error is not a viable explanation for these results, though there is still a possibility that the null is true. When, however, a result is reported as statistically significant, the tendency is to claim that it's practically significant. And in fact, one of the best examples of this is the research on what's called the different cultures thesis, or popularly called Men Are From Mars, Women Are From Venus. That men are from one planet and women are from the other, because we find statistically significant differences between the biological sexes on average on a variety of different measures. But in fact, those differences are very, very small. Take, for instance, the research on fMRI research, where it looks at men and women's brains, and you find a statistically significant difference between the average male brain and the average female brain. That difference actually pales in comparison when compared to male brains and female brains. In other words, there's much more variability within men and within women compared to the variability between the average man and the average woman. I have a specific example here that I pulled from a study that I recently read that basically is interested in the differential impact of presenting people with statistical evidence versus presenting people with narrative-based evidence on their attitudes towards some issue. I think in this study they were the issues they chose were like tanning and some other issue that's relevant to the particular sample that they had. So in one condition, participants are exposed to claims that are backed by numbers, and in another condition, participants are exposed to claims that are backed by personal stories. For a few dependent variables, what you see here are all of the dependent variables: counter-arguing, total number of responses, agreement, miscellaneous, trustworthiness, expertise. All of those are the dependent variables. And for two of them, the first two, counter-argument and total number of responses, you have a statistically significant result. What they did is they presented an asterisk and basically said that there's a difference at the 0.05 level, which is the conventional level for asserting that something is statistically different. Okay, so you've got those two statistically different results. So people who are exposed to the personal stories are less likely to think of arguments opposed to the evidence when compared to those exposed to the statistical arguments, and that's represented by the 0.61 and the 1.23. So these people produce fewer counter arguments on average than these people, and that difference is statistically significant. As you see here, these people agreed a little bit less than these people, but you can basically say that this difference is ultimately zero, that it could be explained simply in this sample, that it isn't something that you can infer about the population. This difference, however, 0.61 and 1.23, is something that we can generalized to a larger population. This is something that's probably happening in the larger population, not just something that's unique to this sample. And that's what this statistic tells you here, this statistically significant result. But even so it's statistically significant. And as a master's student, I learned to say, yay, statistical significance. But even so, the magnitude, which is represented here with eta squared, is very, very small. As you can see in that far right-hand column, that eta squared value is 0.06, meaning that condition, exemplar versus statistical, explains only 6% of the variance in counter-argument. Basically, the counter-arguing scores vary about the mean. So these scores vary about this mean, and these scores vary about this mean. And the authors want to explain that variability. Is there anything that can account for why those scores vary? And the answer is yes. Condition can account for variability, but just not that much of it. Another way to put this is that if all I knew about you was that you were in one condition or the other, then I could guess whether your counter-arguing would be higher or lower, and I would be right approximately 6% of the time. So while it gives us some information about counter-arguing, it doesn't give us a whole lot of information about counter-arguing. So the 6% statistic is an effect size, which we introduced briefly under descriptive statistics. If you were to conduct this study or a similar study several times, you would come up with a range of effect sizes. Some studies would find 0.06, some studies would find 0.13 or 0.01 or 0.10, or some may even find 0, some may even find some negative numbers. In other words, that the statistical group is lower than the exemplar group. You may even have some of that going on. But if you did this, if you did all these studies and then you averaged all of those effects, if you got the mean of all of those effects, you would have a better idea of the true effect of exemplar versus statistical evidence than you would if you only relied on this one study. And the process that I'm describing here is basically called generating a confidence interval. And you can do this with a single study, and you can do this with multiple studies. And so I'm going to show you how to sort of do this, or at least I'm not going to give you the math behind it, but I'm going to illustrate through example what a confidence interval might tell us that statistical significance doesn't tell us. And so a confidence interval is basically an estimate of the approximate values that the population parameter is likely to take. In other words, although I have a point estimate, in our case 0.06, that suggests a viable descriptive statistic for my sample, that might not actually be the true effect for the difference between exemplar and statistical evidence. But if I can assume that my sample is somewhat representative of a larger population, 0.06 gives me a decent estimate from which to generate what's called a confidence interval. So in our case, we've got these data again. You can build a confidence interval around these descriptive statistics. Let's take, for instance, this mean, 0.61, and this other mean, 1.23. And if I do the math behind this, I get a 95% confidence interval for the exemplar group of between 0.38 and 0.84, and I get a confidence interval for the statistical group with a mean of 1.23 between 0.80 and 1.66. What this means is that I can be 95% sure, because remember my p-value is 0.05, I can be 95% sure that the population value of counter-arguments for people like this exposed to exemplar evidence is between 0.38 and 0.84, and that the mean and that the population value of counter-arguments for people like this exposed to statistical evidence is between 0.80 and 1.66. I'm not 100% sure. I'm 95% sure that the value falls between 0.3 and 0.84 for this group and 0.80 and 1.66 for this group. If I'm interested in this sort of population inference, these are important data. When you read public opinion poll results, the margin of error is basically a confidence interval for the mean attitude values reported. The mean is our best point estimate of the population, but it's just an estimate. There's still the potential that I'm wrong. Similarly, there's still a chance that I'm wrong in my inference about whether exemplar evidence confers an advantage in terms of getting people to counter-argue less with my position. As you can see from the confidence interval data, the values of 0.80, 0.81, 0.82, 0.83, and 0.84 are shared between the two conditions, meaning that it's possible that people exposed to exemplar evidence produce a similar number of counter-arguments as those exposed to statistical evidence. So what the effect size tells you is sort of how different those means are, whereas the confidence interval estimates provide you a range of values about which your population mean is likely to fall, which allows you to make a little bit more nuanced conclusions about, in this case, how important is it whether I present people with exemplar evidence or statistical evidence. And what this suggests is you probably will have an advantage, but it won't be all that great. And so the practical value of exemplar versus statistical evidence is then in question. So even if we're not going to question the statistical significance, there is a difference for this sample. It's probably the case that there's a slight advantage in the population if you present people with exemplar versus statistical evidence. The practical payoff may not be all that great. So you're a statistical consultant for an ad agency who's trying to tell their client to build their campaign around exemplar evidence because it makes people counter-argue less, and therefore they're probably more likely to buy into your argument. You're the statistical consultant, and you're like, well, I mean, how much money are you spending, and is your return on investment going to be all that great given the amount of money you're spending on making sure that you're producing exemplar versus statistical evidence? What all of this suggests, in my mind, is that Peirce is right. Science, in all its capacities, is about settling opinion. The best settlement will come from data that's strong enough to help support inferences of primary interest. And knowing how to present those data and make a principled argument is therefore of the utmost importance. As I did last time, I've listed a few readings on this last slide. I've got several other readings if you're interested. I can provide copies of any of these that you're unable to or have trouble locating. I'd like to thank you for your time because I certainly have enjoyed mine.